Word. Okay. All right, and just to confirm again, everything all clear? You guys see it okay?
Yep.
All good. Yep.
Conditions and everything.
Okay, so this is the Sagnac effect in GPS and also the linearized Sagnac effect, which means that it's not due to angular rotation. So general relativity is also insufficient to give an explanation to it. And we'll go over we'll go over the problem at hand here, and then I'll break down the components to it. So we can all figure out what's going on and see where we can, or see where it can be attacked from a point where it would actually be addressing, what's going on here. So a summary of the argument before breaking down the components. The variance of C. The variance of C is revealed when measured in the preferred reference frame, which is the ECI, a frame that is stationary and non-rotating with respect to a stationary with respect to Earth rotation on the surface, or you could equate that to ether wind. This coordinate system, you're going to find it's literally interchangeable with how you interpret Earth rotation with being stationary relative to an ether wind. So, I'll make, references to that. That's what I'm talking about. This is literally just a perspective change right here. So this measurement is performed using the range measurement equation in a time interval system such as GPS. So we're going to get into how GPS works and how all this applies and how this shows the varying speed of light in a preferred reference frame. So the preferred reference frame, the discrepancy arises when transforming the distance derived from the range measurement equation in the ECI to the ECEF or anything really. So we'll get into that. It shows that the value of C is not equal to the value of C in the ECEF. If C were truly invariant in all reference frames, then the distance derived under transformations would also be invariant. So this is a huge problem, and as we move forward, I'll get into why. Mathematical structure violations. The violations of Lorentz covariance contradicts the mathematical framework and the rules therein which govern the laws of physics during coordinate transformations. Consequently, it falsifies the two postulates of special relativity and undermines the philosophical explanations derived from the mathematics, such as length contraction and time dilation. These explanations become superfluous and unnecessarily verbose, as they say. The principle of relative simultaneity is also invalidated. There's a conflict between so-called global simultaneity and so-called relative simultaneity, another principle of special relativity, which the accuracy of GPS depends explicitly on violating that principle. So these are the core issues at hand, and we'll get into the specifics of each one as we continue. Any questions so far, boys?
Yeah. So, okay. I was saying it's showing the same slide. Are you going to there? Now I just saw a different slide. Now we're back to the first. Now we see. Oh no.
Really?
You were
Okay.
reading.
Okay.
Yeah.
I see. Okay. I see. 1 second. 1 second. I know what the issue is. I can't present it in full slide screen mode, so I apologize about that. Because
You kind of the window and not the application. The application,
exactly.
then you can't. Then yeah, sorry.
So go to where you set up the stream.
right.
Go to slideshow. What's it called on there? Setup slideshow. So if you go to slideshow.
I'm just gonna do share screen and then do the whole thing.
Yeah, that'll work.
How's that? And then when I get to the video part, I'll switch it back so you can hear the audio. And then
Man's got it.
Yeah, we'll just.
I didn't know you had audio, but that's how you have to do it. So you're all over it.
Yeah. So we're good. We're good. So current slide. So here's where we're at. That's where I was reading from. These are the arguments at hand. And then, like I said, we'll go over the components. So if there's no questions so far, we'll go ahead and move forward. Oops, that's the wrong direction. So let's go ahead and hit the right one. All right, so we'll go ahead and read special relativity's postulates right from the source. So we'll start from right here. Examples of this short together with unsuccessful attempts to discover any motion relative of Earth relative to the light medium suggest the phenomenon of electrodynamics as well electrodynamics as of mechanics possesses no properties corresponding to the idea of absolute rest. They suggest rather that has already been shown to the first order of small quantities, the same laws of electrodynamics and optics will be valid in all reference frames for which the equations of mechanics hold good. We will raise the conjecture, the purport for which will hereafter be called the principle of relativity. To the status of the postulate and to introduce another postulate, which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity of c and is independent of the state of motion emitting from a body. These two postulates suffice for the attainment of the simple and consistent theory of electrodynamics of moving bodies in accordance with Maxwell's theory for stationary bodies. The introduction of the luminiferous ether will be superfluous in so much here as that there will be required no absolute reference frame there will be no preferred privileged reference frame, right? So that's basically what he's saying here. So these are the postulates directly from the guy. So here's a brief summary on what we just read. In the analogy presented by Einstein, so by the way, he derived these postulates right from the motions of a moving magnet over a conductor and vice versa. And in that observation where one generates an electric field and one generates a Lorentz force, a repulsion force, he concluded that based on that, all reference frames are invariant. So it doesn't matter where your reference frame is, there's going to be a reaction. And that's kind of the basis for how he came to this conclusion, right? So, and then he's basing the speed of light off of the misinterpretation of the Michelson-Morley experiment. So we'll continue on here. So in this analogy presented by Einstein, he explains that regardless of Earth's motion, the null result of the Michelson-Morley experiment is predicted by special relativity because the speed of light is invariant. This means that the speed of light remains the same in all inertial reference frames, and that is therefore there should be no fringe pattern detected in Earth's motion. In the case of the electrodynamic relationship between the respective motions of the magnetic field and the conductor when the magnet is in motion and when the conductor is stationary, the magnet generates an electric field which interacts with the conductor, inducing electromotive forces, EMF, and subsequently the electric current. Conversely, the inverse relationship with a stationary magnetic field in a conductor in motion will induce a magnetic field that results, basically the repulsion force. So they call that the Lorentz force when it does that. And then Einstein concluded based on that with this relationship with motion, that all reference frames are equally valid and that there will be a reaction either way. So here's a summary of that summary, just to further break it down. Special relativity is validated through co-opting the Michelson-Morley experiment, which failed to produce a fringe shift reading corresponding to a velocity of 30 kilometers a second. To their dismay, a reading of 5 kilometers to 7.5 kilometers was given. To give this measurement, to explain this measured fringe, they attribute it to instrumental error instead of an actual velocity reading, and they said that the speed of light was actually, invariant from that, and that's where Einstein derived that from. And keep in mind here, so these asterisks here, these measured translational speeds, 5 kilometers and 7 kilometers, are according to the scale derived for what they expected the fringes to be for the orbital velocity. So they didn't even actually measure anything moving at 5 kilometers a second. This is just relative to the scale that they made, to give some perspective on that, because you're going to see that that because the Sagnac effect is linearized, you're going to see that there is a varying speed of light, and what they seem to measure corresponds with an ether wind. So I just wanted to be clear about the translational speeds. This is relative to the scale that they made, trying to on what they thought one fringe would be equal to. So they thought that one fringe would be about 5 kilometers a second, and then they expected that they would get about, what is that, like 5 or 6 of a fringe or whatever. So they were way off. But yeah, this scale is just relative to what they thought. And then so to continue on here, let's see. To explain the measured fringe, this is attributed to instrumental error. And they said that, the speed of light is the same in all frames. This is claimed unsubstantiated, of course, because the Earth's assumed motion around the sun, and therefore there must not be a stationary ether to measure the relative motion from as an absolute reference frame. By claiming that the fringe is effectively zero, the experimental results could be interpreted as proof of an invariant, or proof that C is invariant regardless of the motion of the source or observer. Regarding Einstein's comparison of the respective motions of the stationary and moving magnets, another postulate is formed. All reference frames regarding electromagnetic and phenomenon in optics are equally valid. Regardless of your reference frame, the moving and stationary magnet conductor effect are produced, and it doesn't matter, although the mechanisms of what is produced are different. The claim here is that the speed of light is the same regardless of the motion or the observer, and that the electrodynamics of moving bodies provides a good analogy to describe the concept of all of reference frames and how the laws of physics must be the same, and that none of them are preferred because for one reason or another there will be a desired relativistic effect. And then this is just adding clarity to the measurement scale. So we'll continue on, and this is a two-worded summary by Professor Jody Cooley, taken from her presentation. I came across this, and there's a couple slides that I borrow from this that give really good explanations to catch us up on the subject matter. So Einstein's postulates: the laws of physics are invariant for all observers in inertial reference frames. The speed of light is the same to all observers regardless of their motion. Okay. Transformations and covariance. So this is the rule book for these transformations, right? So we've all heard of transformations, equations, and all this stuff. This gets into the specifics of the rules for them. So we're going to learn about that. So transformations and covariance, rules for coordinate system and transformations. So this is taken from Wikipedia. This is just a brief overview to get your foot in the door. I highly recommend, obviously looking at actual papers about the theory of covariance and all this stuff, but these were actually pretty good summaries. So go ahead and read them off and get everyone familiarized with the basic rules here and how they apply, so we can start to see the issue with what Wang is going to bring to the table here. So Einstein's theory of does anyone have any questions so far? Are we all clear on the postulates and how Einstein derived them? Make everything make sense so far?
Yes, sir.
All right. Einstein's theory of special relativity. Like Newtonian mechanics, let's see. However, because special relativity postulates that the speed of light in free space is invariant, the transformation between inertial frames is the Lorentz transformation, not for the Galilean transformation, which is used in Newtonian mechanics. Not super relevant here. The invariance of the speed of light may seem counterintuitive. It leads to things such as time dilation, length contraction, and relativity of simultaneity, which have been extensively experimentally verified. If you think these things have been highly extensively verified, I highly recommend you look at my presentation titled "How Math Became Reality" and familiarize with all the so-called solid proofs of these things. Sorry, got ahead of myself. So Lorentz covariance. In relativistic physics, Lorentz symmetry or Lorentz invariance, named after the Dutch physicist Hendrik Lorentz, is the equivalence of observation or observational symmetry due to special relativity, implying that the laws of physics stay the same for all observers that are moving with respect to one another in an inertial frame. It is also described as a feature of nature that says experimental results are independent of the orientation or the boost velocity of the labor through free space. So Lorentz covariance. So it has two meanings here, and the one that we're interested in is an equation is said to be Lorentz covariant if it can be written in terms of covariant quantities. Confusingly, some use the term invariant here. The key property of this equation is that whatever is being transferred holds true in the new coordinate system that it's being transferred to, and if it doesn't, then basically the whole structure collapses. And so if you're going to take a law of physics or whatever, these things have to be coordinate transferred. What is it? Invariant, right? These have to be invariant transformations on the transformation. So we're going to see how all this is applying here. So thanks again to Professor Jody Cooley. So consequences for Lorentz transformations. The quantity or what does it mean for a quantity or law to be invariant? The quantity or law remains unchanged when after undergoing a transformation to a different coordinate system. So non-invariant quantities. So these would be things that are like normal axis, like an x-axis, or some relative speed, and then transferring that to another coordinate system. That would be a non-invariant transfer. So you could transfer something for that, and there would be a loss there. So when you do an invariant quantity, a law of physics, right? So some particular rate of acceleration or whatever, or mass attracting mass, for example, or C, then when you transfer to a new coordinate system, everything from that has to be an invariant transformation. There can't be any discrepancies. If there's discrepancies, that means that you're not doing it right, and the laws of physics aren't being represented accurately through the mathematic structure. And from that, there's not really like a way to repair that. You'd have to like fundamentally start over with your postulates, right? Because if your postulates aren't true in nature, why would you continue to build a mathematic framework based upon it, where you say everything's true in this framework that I made up, where it's clearly not true in the one framework that we can measure, right? So it doesn't make any sense. So you're going to see the extreme of that moving forward here. So before we move forward, any questions on the invariance and transformation rules for that stuff? Okay, cool. So we're going to get into Wang's GPS paper now and apply what we just learned. We'll read through here some of the highlighted section. So the mathematic structure violations. The C in the ECI is shown not to be the same when transferred to other coordinate systems, when it should be invariant under transformations according to Lorentz covariance. Going all the way back to Michelson-Morley, this non-invariance issue invalidates the justification to assume C and then transform to a new reference frame ad hoc to explain the invariance shown in the Michelson-Morley experiment. And what that means is, so you know how they originally said, hey, it's actually an error discrepancy and C is the same. Well, when they were proposing the reference frame system, they actually said, if you transform to a reference frame on the sun, you'll see that the device hasn't contracted, and that from our reference frame, there's an actual contraction of space-time, and that's the mechanism that did the contraction. And only from the perspective of the sun would you see it. So the justification to even get into that sort of mathematical role play is dependent on the variance of C, and that's going to be shown not to be the case. So the abstract here, the successful operation GPS is based on the range measurement equation with the in the ECI system, and it is indicated that this, through all this, that the Segner effect is not a relativistic effect, and that the relativity of simultaneity is also contradicted by the basic operations of GPS principle. So here Wang goes over the GPS range measurement equation to get us familiar with it here. So we got R sub R times T sub R minus R sub S times T sub S, and this is the coordinate system location of the transmission time, and transmission time, and then the coordinate system of the reception time, and then this absolute value is equal to C times the transmission time minus the reception time. Multiply those, and then you get the you'll get plus or minus to C, and that's what they're going to derive the accurate distance from using the range measurement equation. So so now that I just explained what that is, we can get into the key points of the paper here. So let's see. The highly successful practice of GPS, especially its unprecedented precision of measuring distance under the order of millimeters, is equivalent to measuring time to the degree of 0.01 nanoseconds, and have proved the correctness of GPS's range measurement equation with the ECI reference frame. Based on that, we re-examined the fundamental problem in physics and all the principles of relativity that we just went over, and the fundamental unsolved problem in physics, the Sagnac effect. And we'll get into the history of that too as we move on, and then and explain why he has this weird opinion that the Sagnac effect somehow invalidates the framework of light that's given to us. So the Sagnac effect, which is extensively used in GPS, here we should emphasize 2 points first. The correct coordinate frame for the range measurement equation is the Earth-centered inertial frame. 2, the most GPS receivers are moving relative to the ECI ground receive stations. So the way that the ground receiver stations, airplanes, cars, etc. So the way the ECI calculates the motion of a ground, quote unquote ground receiver, right? It would be from the perspective of being at the center of the ball where you're not experiencing any orbital velocity or rotation, and so you're stationary, non-rotating, and then the Earth's surface is rotating with respect to you. Now, if we're on a stationary, non-rotating plane, the same, literal same coordinate system would just be with respect to an ether wind. We can, I'll get into that towards the end of it. But that's the other interpretation of this coordinate system and how it interprets motion. And we're going to, in fact, see that Earth rotation motion in the way that they're trying to describe it doesn't even exist. So obviously, the definitions for the position for the receiver at the reception time is important for a moving receiver, since the reception time and the position of the moving receiver is different for the position of a stationary receiver. And then he restates the range equation here. Let's see. Hold on a second. Okay. So the difference between now he goes in to talk about the difference between the how GPS derives distance and how you would traditionally derive distance, right? So the way distance is derived with the GPS is it's a time interval system based on the range measurement equation. So it's taking a snapshot of the coordinates and the time that it was sent, and then it's taking the time delay to get to the receiver and multiplying that by C, and then or subtracting that and then multiplying that by C, and then that's giving the accurate distance. So the traditional way to do it would just be having 2 points on a coordinate system, and then at any particular point in time or whatever, you just know the distance between those two coordinate systems, right? Because you've already established the units for it. So so the traditional distance is invariant for the coordinate transformation between two systems moving relative to one another, but the range P derived from the range measurement equation in the ECI is not invariant for even a simple Galilean transformation. So when you derive something in the ECI, when you derive a distance from the ECI and you try to apply it to even just moving the x-axis, just by applying a little bit of velocity to the x-axis, the distance messes up with just one coordinate or just one axis change. So he's saying just imagine what happens when you transfer it to the ECEF. It's not gonna even be close because it's already messing up at such a low level of transformation. So the variance of C, rescaling. Or did anyone have any questions so far?
No, keep going.
No,
Or maybe not.
as long as just make sure everyone knows, like you have ECI, and that's being the inertial system, right?
Yes. I'm sorry, you cut out a little bit.
That's all I was saying. Is that the ECI is it's the inertial system?
Yeah, the Earth-centered inertial frame, and then the ECF is the GS87 ellipsoid that they say. So that the way they do the measurements on that is different because the way that they account they don't have a relative motion for that on there, so they don't have that fixed frame or whatever to derive relative distance or to derive the correct speed of C. So that's what's causing the discrepancy in the coordinate system transformation. That's what's being revealed here slowly.
Boom.
Yeah, you were saying that there's been a couple misconceptions that you've overheard or heard about from some of the ballers.
Yeah, we'll get into those at the end, because like some of them are going to be like self-evident, because this is like, it way undermines any attempt to even try and explain it through relativistic means. But to even give it to the benefit, like I'll play ball a little bit and explain how like it's still not even the case.
Cool.
But yeah, we're good. So so we'll continue on here. We're all up to speed on the coordinate system transformations and how there's a Lorentz asymmetry going on, right? So it's not an invariant transformation. So we got a big problem here, and we'll continue on. All right. So the variance of C, rescaling that GPS time. Oh, I'm sorry, recalling that GPS time. The GPS is a time interval system that derives distance by an assumed fixed value for C, and that the time difference between the signal transmission time and the signal reception time difference is multiplied by C. It is in this respective coordinate system. C is shown to have a preferred direction of propagation, east to west, for a plane with a ether wind, translate the motion of the sky, and west to east on a globe. It's just inverted based on how the math is derived on the way that you guys perceive. I'm sorry, that the way that the globe, the way that they explain the sky is that it's a counterclockwise rotation. So on a stationary plane, it just inverts. So that's the discrepancy there. Because the way that when you research this through the glob lens, right, it'll be framed through west to east. But it's
yeah, that's the thing that we figured out with geos, and I was asking too as well, as far as like the movement of the sun. Does that correlate with the movement of the ether wind? And then you figured out that, yeah, it was actually the reverse interpretation that we usually get with a lot of these things.
Yeah.
Also, just to make a note, that it sounds, another thing that I've discussed with you is that it's reifying that there's a speed of light by saying C and all this. But just, for anyone listening, that this is actually the propagation of light through the medium of the ether that we're talking about in general, but they have to use C as a way of explaining it.
Yeah, well, there seems to be like a relative, like close enough value, right? But when they get real specific with it, and they actually try and do transformations with it, it's not the same C that they're telling everyone. Like they're talking about a different C. You know what I'm saying?
Right.
Yeah, that's interesting.
Yeah.
A rate of induction.
Right. Yeah.
Exactly.
Yeah. So yeah, and what they're showing here with the range measurement equation in the ECI, when you actually measure the relative motion of it, there's a varying speed, and it's showing a preferred direction of propagation. So this will go into play with the description of the ether wind, and then it's just going to be interpreted relative to a stationary non-rotating plane. So we'll continue on.
An absolute reference point.
Yeah. A preferred one, if you will, right? Because we're getting the correct derivation of C to derive distance in this reference frame. So it's a preferred one, right? Like it's real bad for a relativist enthusiast. This effect is attributed to the Sagnac effect, which is said to be the equivalent of the signal receiver rotating away from the transmitted signal, which is causing the variance in the speed. So we'll see what Wang has to say about the range measurement equation and how this all works. Some people think that the range measurement equation is based on the constancy of the speed of light on the surface. This may appear to be true. The speed of light is the only velocity term that appears within the equation. Expressions such as C minus V and C plus V, which are often seen in discussions of special relativity in classical physics, do not exist in this equation. Therefore, some people would conclude that if this equation is correct, that special relativity is correct. If this equation has been proved to a high degree of accuracy, special relativity has been proved to a high degree of accuracy. For example, it has been concluded that special relativity has been confirmed to a very tiny number here. But we do not judge things for their appearance. We must try to grasp their essence. If we analyze the implications of the range measurement equation carefully, we will find that contrary to what its appearance tells us, that what some people think about the correctness of GPS's range measurement equation actually leads to the incorrectness of the principle of the constancy of the speed of light, and furthermore, the principle of relativity. And then continuing on here, this may seem unexpected, but it is quite understandable if we compare it with sonar systems. Recall that in underwater navigation, sonar uses the same range measurement equation in a reference frame based on the water to calculate the distance traveled by sound, sound, even though the sound receiver is moving relative to the water. The difference there is that the speed of sound A, that they use the speed of sound A in the equation instead of using C, the speed of light in a vacuum. However, no one would emphasize the constancy of the speed of sound, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the sound receiver. So, same exact equation, using a different wave medium, derives the correct distance. It reveals that there's a relevant speed to the thing that's propagating, right? Dude, everyone up to speed?
Dun, dun. Do any ballers want to explain this part to me? I can't make this make sense from your paradigm. Well, maybe.
Yeah, if you're gonna make comments, make a specific comment rather than so many misunderstandings.
Well, no, dude.
So-
Yeah, it will let this serve as like the ultimate, guide, so to speak, on it, because it's been done several times and people get different renditions of it, et cetera, et cetera. So like, let this serve as the solid one where everything's laid out, all the context. Because some of the stuff I kind of didn't realize the gap barrier on the transformation stuff. Like, I thought that people that were knew about that stuff, knew the rules and everything to it. So I didn't realize how to specify or how to break this down and make it digestible. So yeah, there's a lot of rules to these things, and they're not following them, and then they're just pretending that they are and telling you and acting like you don't know what you're talking about when you question it. Is basically where we're at so far.
That's all we've gotten so far. Keep going,
and to the Globers, to give them credit, like, this isn't your guys' fault. Like, you guys all think that you guys got it pegged and stuff. It's crazy, man. It's real unfortunate. Like, we all wanted to believe in this stuff too, and it's real unfortunate what they've done. So this is just a reiterate. Sorry, go ahead.
I was just gonna say, somebody said the baller respond. I mean, I was gonna respond to it at the end.
Okay.
But based on that request, based on what you just said, also, it's quite funny that this guy Wang, he says a lot of incorrect things, and you guys aren't really catching it. But he just said that everyone agrees that there's no consistency to speed of sound, and based on a moving object. But a moving object doesn't change the speed of sound. I don't know why he said that.
Oh, so you didn't address my question about how they're using a different value and just switching out the variables with the same equation?
No, I'm responding to this thing where it says, however, nobody would emphasize the consistency of the speed of sound. Contrarily, everyone thinks the speed of sound is dependent on the motion of the sound receiver. But that's not true.
Wait, so we are just ignoring the part where you guys put in a different variable in the same equation?
We're not ignoring anything. Like I said, there's a lot of stuff to respond to. I was going to wait to the end. I'm specifically responding to this part right now, since that's the last thing that he said. Literally. And
Hi, guys.
it just isn't true.
Can you explain
well,
exactly why it's not true,
they're
and
not
what exactly your interpretation is of what was said?
Yeah, that's not what he's saying, though, right? However, no one would emphasize the speed of sound that the speed of sound has, I guess, constancy, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the sound receiver. Is it not? Is it not dependent?
Isn't the wavelength?
Doesn't the So how they're using the range measurement equation, though, for sonar, wouldn't it be dependent on the motion of the receiver through water?
So I think in the same way, the speed is not changing. It's just the wavelength in that case.
Sure. Okay. So
Oh, wait, you said he's got a lot of things wrong, and then
Wait,
you
wait, is the
pointed out
distance
one
over
that was
time
like not
changing?
even.
I just wanna know, is
Yeah,
the
we
is
can
the
go
distance
over the whole
covered
thing.
over the time
yeah.
changing?
No, let's just look through
See,
it.
I think
Yeah.
The
that's
speed
Yeah.
doesn't change because
Yeah. Let's continue on, and then we'll stick to the end. Then it's good that you have input for the end. I was getting a little worried that no one was going to have anything to say. All right. So
wait, what are you guys watching? Well, just pay attention, you'll find out.
all right. So just to go over how distance is derived again, how he was saying you have two coordinates, and then you just derive the distance from the coordinate system or whatever, and then the GPS time interval system, takes a snapshot of when it was sent and the time and time of reception, and then you multiply the discrepancy by c, the reception time and transmission time. So here in the ECI serves as a stationary non-rotating frame for the relative speed of electromagnetic propagation to be measured so that the distance can be derived, determining the absolute values of the location and time of the signal source and receiver in the ECI coordinate system, and then subtracting the difference from C and then multiplying it. Using the ECI reference frame, C can be used to determine accurate distance down to the millimeter in this coordinate system. In this equation, the ECI is the relative velocity of C being measured with respect to an absolute frame, stationary non-rotating frame, right? So if all reference frames were equally true as per the postulates of special relativity, then the distance derived from the range measurement equation in the ECI being proportional to the invariant speed of light would be invariant when transferred to another coordinate system that uses C as invariant. However, it is shown that when transferring to another coordinate system, the distance must be again corrected, this time within the confines of relativistic effects such as time dilation, length contraction, etc., which is begging the question after the postulates aren't even true from the reference frame in which they were derived in. The accuracy of GPS is dependent on the absolute reference frame to measure the relative speed of electromagnetic propagation, or to measure the speed of electromagnetic propagation against. The preferred reference frame, stationary non-rotating frame, is the reference frame to which all other reference frames is derived from. That might not be true. Said that wrong. That's not entirely accurate. The invariance of that's not what I meant. The invariance of C shows that there is an absolute background that sets the speed propagation for light, and is shown that and through this there is shown to be a preferred direction west-east, and that's for your guys, through your guys' counterclockwise paradigm. So again, just coordinate systems. So if you wanted to determine the distance, traditionally you would just say you were here at C2, this, and then this tile here is at F6, and the distance between them is 1, 2, 3, 4 tiles, right? And then GPS is saying, we'll take a snapshot of the time here and we'll calculate the propagation, and then, oh, you got it here. The propagation is C. Oh, you got it here. And then we'll subtract the difference and multiply it and figure out the distance in between here. So that's the difference in the coordinate systems. Long way of doing it. If you guys preferred this method of explanation, let me know so I can make it faster next time. So the Sagnac effect. So this is where Wang gets into the Sagnac effect and a little bit of the history of it. So, for example, the Michelson-Gale experiment examined the effect of the rotation of Earth instead of the rotation of the disk, and the Sagnac around the world experiment recorded the signal arrives at atomic clocks instead of interferometers. So this was in reference to Heffel and Keating. Their atomic clocks also went out of sync, invariant, or corresponding to a preferred direction. Right, the east to west propagation was the worst for them, or west to east from your guys's standpoint. That had the most variance in the clocks. So that's what he's relating to it there. Let's see. The Sagnac effect has been applied to many systems ranging in size from a few centimeters and fiber optic gyroscopes to global positioning systems. Especially, there will be a positioning error of about 30 meters in GPS if the Sagnac effect caused by Earth's rotation is not considered correctly. Although nobody understands the existence and importance of the Sagnac effect, the interpretation of the Sagnac effect is still a very controversial topic, and there are more than a dozen ways to interpret the Sagnac effect. As mentioned above, it is stated that the Sagnac effect is an unsolved fundamental problem in physics. Here, we would show that the Sagnac effect could fully be interpreted through the range measurement equation. So this angular momentum derivation provided by GPS, provided by general relativity through Paul Levine's metric is going to shown to be not necessary here, because he's going to derive it he's going to derive the Sagnac effect from the equation itself. Already calculates it. He's going to also show the linearization of the effect, and then he's going to use that linearization to calculate the circular effect, and then he's actually going to show that the circular effect is actually just calculating for the length, and it's been a ruse the whole time, boys. All right, so continuing on here.
And just real quick before you move on from that slide, just in case there's anybody listening that was just hearing what you said, you misspoke on it says, you said although nobody instead of although everybody understands.
Mhm.
But it's everybody understands just to let you know, just to make sure there's no.
Everybody understands the Sagnac effect, but the interpretation is controversial.
Yeah. Oh, yeah. Okay, sorry, I did. Okay, yeah. Although everybody understands the existence and the importance of the Sagnac effect, the interpretation of the effect is still a very controversial topic, and it has more than a dozen ways to interpret it. So yeah, in my research, I came across quite a few ways to explain it, but none of them are sufficient insofar as again, if the postulates of the theory of the framework aren't even true, why would you then proceed to say, but then if the length contracts and no, sorry. So this is a lot of the crux of the issue here with this, is that this is derived outside of relativistic means entirely, and is shown to be a literal ether wind preferred direction that you can measure when you use a preferred frame to accurately measure the distance. So Sagnac effect derived from the range measurement equation, no relativistic effects here. Interpretation of the Sagnac effect with the range measurement equation, and then he just kind of goes over the math. So what he does here, so he takes he takes 4 GPS receivers, right, in orbit or whatever, at a location around there. He basically builds a big Michelson-Morley device with GPS signals, and then uses the same equation to derive the exact same results that have already been shown, but just shows that the equation derives the effect the exact same way if you were to derive it from the circular effect that they say is explicit to the non-inertial frame of the rotating interferometer or whatever, right? So this is kind of what he's showing here with that. So the last expression is that the same results of the Sagnac experiment. This tells us that the range measurement equation used in GPS in the ECI can interpret the can interpret the result of the Sagnac experiment perfectly. It also tells us if we utilize the real propagation paths in the ECI to calculate traveling times of the signals, the Sagnac effect is included automatically. So yeah, there you go. So here I'm gonna switch to audio real quick. We're gonna listen to Ron Hatch, the guy who owns 27 patents in GPS, was called in to fix the relativistic corrections that weren't working, and he actually makes some comments on Wang's work and has some input on the circular and linear division of what Wang did, and I think he puts it in a very easy to understand way, so it'll be super helpful. So let me change things here. Oops. Let's see. Okay, let me know if you guys can hear the audio. Oops, maybe if I hit play.
Okay, a little more.
Solid?
Yep.
Yeah, we can hear it.
All right, going in.
One-way Sagnac effect on the Earth. The measurement is the result of Earth's rotation around the Earth. I claim that that's absolutely false. Wang has done some experiments with conveyor belts and shown that their circular equation right there is really equivalent to the length and can be put in terms of the length. Well, on one-way path, you'd expect it to be half as big. The GPS experts claim, there's this triangle that it follows, and they put it in the same form for a one-way because of Earth's rotation. But again, if you work it out, it turns out it's just VL over C squared. And when you put it in terms of where the satellite and receiver are, it works out to be exactly the same as that VX distance along the equator. And so there's clock biases that have to be accounted for in GPS to remove the Sagnac effect. Everybody asks why there isn't one for orbits. Well, there isn't one for orbits because they're all affected by the same amount. You just adjust your clocks. The clocks have been adjusted and are automatically kept that way from the argument we've already given. A little bit more proof of that is GPS has to include all receiver motion in the effect, rotational, and not whether it's just rotational or not. And that's the ICD document that claims that that's the case. So again, it's not a rotation, it's a fact that the receiver and source are moving. Which incidentally, I came across a paper a long time ago, I haven't checked on it recently, when they tried to compute precise orbits with radar of the planets. They did not get the right values, and they tried it with and without Einstein's theories, and it didn't work either way very well. I claim that they're not taking into account this flattening effect and the speed of light changes as a function of direction here. The length contraction is different in different directions. And
the length contraction is different in different directions, boys. So are we all up to speed on the linearization and how the circular equation is equivalent to just the being the distance? So it's a linear effect. So to get into one of the ways that special relativity tries to say that this is a relativistic effect is that it's that it's not a red flag for relativity, is that the Sagnac device is a non-inertial reference frame, and that because it's rotating, the laws of relativity don't apply to it, blah, blah, blah. So they have, wiggle room, so to speak, for that. Now, what Wang did here and what your boy just laid out about all that is that that's not the case, and that the Sagnac effect is not dependent on rotation. So it's within the confines of being, it's subject to relativistic interpretation, and so it's invalidating the postulates right there, right? So as long as we're all up to speed on that, I think he might have, I think that was it. So yeah, basically at the end there, he was just saying that when they did this radar thing, which isn't relevant, but he says that none of the equations worked with Einstein stuff or the Newton stuff, and that he thinks it was due to light having a flattening effect, and he's attributing it to that preferred direction, right? But he's not realizing that it's a stationary, non-rotating plane. He's still trying to interpret it through the globular paradigm. So, all right, so we all caught up on that.
Yeah, sure.
Don't forget to switch back to window sharing if you're going to go back to presentation without sound.
Oh, thank you, sir. Thank you. Give me 1 second. Change windows, full screen, and
Dude is nailing it.
oops. All right. So the Sagnac effect is a non-relativistic effect. The Sagnac effect is not due to angular rotation with the confines by which general relativity attempts to co-opt the Sagnac effect is invalidated without GR's angular rotation solution provided by Paul Levine. There's no mechanism to explain the effect within general relativistic means. Wang demonstrates that in an inertial frame, there's a varying speed of light. This is a violation of special relativity's postulates, rendering the framework untenable and unable to answer the Sagnac effect without ignoring the fact that C objectively varies in a preferred reference frame. This means that the Michelson-Morley experiment was not a null result or due to experimental error. The velocity scale in which they applied the friendship patterns to was just off. Michelson, Gale, and Sagnac are essentially the same exact experiments as Michelson-Morley. if the Michelson Gale and Michelson, I'm sorry, if Michelson Gale and Michelson, a tale of two Michelsons, right? If Michelson Gale and Sagnac detected a fringe corresponding to a sidereal rotation, then Michelson Morley must also be a valid detection. The only difference here is that the scale invoked to interpret the results for the orbital velocity. Therefore, it's completely unjustified to transform into a reference frame for an observer on the sun to theoretically explain length contraction that would have already happened in our frame to derive the correction needed to infer Earth's alleged orbital velocity of 30 kilometers a second from a 5 kilometers a second reading, and then to turn around and use the same fringe reading as a 15 degree per hour reading and correlate that to Earth's rotation relative to the latitude. Any questions before we move on to relative simultaneity versus global simultaneity? Okay, relative simultaneity versus global simultaneity. In any debate about the speed of light, the problem of simultaneity is always a focus. Thus, special relativity claims that relativity of simultaneity, which states that two events occurring at two different places which are viewed as simultaneous for an observer in a system, usually will not be simultaneous if viewed for an observer in another system. And Wang is being generous here by saying usually, it's never. This is the postulates of special relativity, so it wouldn't be. So keep that in mind. But contrary to this, simultaneity is key to GPS operations. GPS is a timing ranging system. It does not directly measure the distance between two places where two events, i.e. signal transmitting and signal receiving occurs. It measures the difference between the difference of the two instances when these two events happen, and then the distance is calculated using the range measurement equation. GPS, especially its space segment and control segment, make a huge effort to establish and maintain GPS system time, or simply GPS time, in a scope where GPS is applied roughly of a scope with a diameter of 50,000 kilometers or bigger. If one is using GPS, one is using GPS time. And therefore the concept of simultaneity of GPS, two events that happen at two different places, and then he gives a coordinate system for one event, and he gives a coordinate system for another event, an X, Y, Z, T axis there. And the events are simultaneous if T sub 1 equals T sub 2. So if the time that these events occurred is the same, then then they happen at the same event or whatever, then simultaneously. This is true no matter who the observer, receiver is, or where the receiver is, what the status is, what speed it is, or what speed it is. This is the basic operational principle of GPS. We call it global simultaneity. In a book about special relativity, the most commonly cited example about relativity of simultaneity is the example of the railway platform and the moving train. It says that two events, e.g. two strokes of lightning, A and B, which are simultaneous with a reference frame or with reference to a platform, are not simultaneous with respect to the moving train and vice versa. But now GPS receivers have utilized extensively, but now GPS receivers have been utilized extensively on railway platforms, in moving trains, and lightning at two different places, A and B, conceptually at the same time, as the emissions of the signals of GPS from two satellites or two GPS stations. In fact, if two GPS signals are emitted from two satellites or two GPS stations at the same time, both the GPS receiver on the railway platform and the GPS receiver in the moving train would acknowledge the two events. The emission of the signal would be simultaneous. Without this basic acknowledgement, the GPS receivers would not function at all. All right, any questions on relative simultaneity?
Yeah.
What do you got?
So you said earlier, can you go back to the other slide?
Mhm.
You said that he's being generous there, that he really meant that two observers never agree on a simultaneous line, right? In SR. But my understanding is that if two observers are at rest with each other, then their lines of simultaneity are the same, aren't they?
Yeah, I think you're right.
Okay.
That makes sense. So yeah, okay. My interpretation of that was wrong then. So yeah, thank you for correcting that. What did you say again? The two stationary receivers would. So you're saying two stationary receivers would see a simultaneous event at the same time, and that wouldn't be a violation.
Yeah, like two observers that are at rest to respect to each other would always agree on simultaneity.
Yeah, that seems kind of common sense.
Okay.
Was it just like a was it just like
Yeah, my apologies.
misreading of it?
Yeah, I was applying it to the reference frames, I guess, really.
It's kind of like what I was bringing up with what Brenner was saying about the whole thing about the movement compared to that stationary. But I don't know if you worked that into this presentation at all. But remember that?
Yeah, you'll have to refresh me. We did touch on that. It was a good point. Okay. All right. So we're cleared up on that. And we'll go to the speed of light relative to the speed of light relative to the speed of light relative to what, and the varying speed of light used in the Michelson scale to mathematically derive the results to interpret the fringe shift pattern, the implication of an absolute reference frame to measure the relative velocities here. And then so from the Michelson Gale paper, the theory of the effect of the rotation of Earth or the velocity of light is derived from a fixed ether hypothesis. And this is just showing that, further stating that they're inferring the fringe shift pattern through a varying speed of light to which they're measuring, the relative velocity against an absolute reference frame. So this is the early GPS calculation essentially, right? So this is how they're doing it. And then they're attributing that to Earth rotation. So we'll get, which we'll get into towards the end here. So we're almost done, boys. I think, let me double check here. So we're at 19. We got a couple more.
I see you did work in the Brenner a little bit in the last slide with what's the speed of light relative to what, right?
Yeah, because that's a really good question. That's what the OGs were pointing out for Sagnac and Michelson Gale. They were like, with respect to what though, but it was just kind of at that, they were pointing towards their higher understanding of the mathematics. Like I didn't get what they were picking, I didn't pick up what they were laying down at the time until, learning more about that stuff.
Cool.
But yeah, that's absolutely right. So with respect to what, right? And this is the ether frame, right? So go back to presentation here. So what is responsible for C's variance? Orbital velocity versus Earth's rotation. Another complete failure for the heliocentric model is that Earth's orbital velocity isn't compensated for the linear motion that would be experienced for Earth's rotation, than when it's also orbiting around the sun. So if they're going to claim that the orbital velocity, the Earth's rotation at around 1,000 miles at the equator is being accounted for, that linear rotation, Earth's orbital velocity of 66,000, or was it 30 kilometers a second, isn't being accounted for in any way. And so the difference being, so if they're accounting for motion in that regard, right? If the Earth's, when the Earth's rotating into its orbit, this effect would have to be added to be in account if the rotation is truly what's causing the variance, and they don't have to account for that at all. So, and we'll just kind of show a representation of what that means. So Earth's assumed and never measured or accounted for orbital velocity of approximately 30 kilometers a second. So going around, and then the daily rotation, the angular velocity, or 15 degrees per hour, the translational speed, was 1,000 miles per hour at the equator, which varies at latitude. And this is from which one is this from? This is from don't remember. I'll look it up in a minute. Anyway, ether becomes very strange. So this is This is in reference to what you were talking about, Dave, with the with respect to what, right? And then so this guy, and then so this guy makes the postulate that maybe there's a local ether that surrounds the Earth, and that's why it doesn't have to account for the orbital velocity, and it only has to account for a varying speed locally, right? Which is also, a complete violation of relativity to do that anyway. But like, this guy, threw his hat in the ring. So anyway, it says, furthermore, while a further examination shows that the displacement of the receiver due to Earth's orbital motion around the sun or whatever is not corrected, it is noted that the orbital motion has a linear speed 100 times that of Earth's rotation. The GPS accuracy of about 15 meters or better in positioning, thus the precision of GPS would be downgraded significantly if the corrections due to Earth's rotation were not considered. On the other hand, the high precision of GPS would be entirely impossible if the omitted correction due to Earth's orbital motion was really necessary. So Earth's orbital velocity has never been inferred. Michelson-Morley was just showing the same thing that they've always shown, that there's a varying speed, but they didn't get enough to match their interpretation for their scale that they had set up for fringe shift. And then GPS specifically doesn't account for the presupposed orbital velocity of Earth around the sun. The orbital motion is a linear speed 100 times that of Earth's orbital rotation, and would have to be accounted for in addition to the daily rotation. The Sagnac effect is revealed in GPS's range measurement equation as an effect to ether wind with respect to a stationary non-rotating Earth. And then there's a couple citations for where all this was derived from. And then so
That's awesome.
Yeah, and then so as we close out here, we have the moving and stationary receiver, the range measurement equation, and the moving receiver. The speed of light is dependent on the translational motion of the receiver. Most GPS receivers are too moving. Some of them are in circular motion. Some of the receivers in ground stations and the receivers are fixed to the Earth, but still rotating. And some of them are in translational motion on missiles, airplanes, and cars, etc. Right? So let us suppose that we have a stationary source and two receivers, one stationary, one moving translationary. So two receivers, one stationary, one moving, and same for the receivers. And then there's a distance of L. Then we will have two receivers at the signal emitted at T0, where the source corresponding, blah, 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 range measurement equation, all that, right? So what they find out here is, contrary to the appearance of the range measurement equation, the speed of the receiver V does not appear explicitly in the receiver, and it is implied from the definition of the position of the receiver and the position of the receiver at the reception time. Compared with the position of the stationary receiver at reception time, the position of the moving receiver at reception time is different. And the difference is proportional to the speed of the moving receiver. So the only varying difference they've ever measured is with respect to an ether wind, and when the guy that's stationary, he gets when the signal is emitted, the guy that's stationary gets the information before the guy that's moving, even though technically they're both experiencing linear motion, and there should be no difference in relativity there.
Yeah, that's the crux of the big biscuit. Go back to that real quick and reiterate, because that's what.
Yeah, so this really reiterates that when you're at rest in this coordinate system, you're truly at rest with respect to whatever is causing the electromagnetic propagation to have a preferred direction.
Otherwise, there would be no difference in the receiving of the signal.
The actual preferred direction, and then that's just what I explained earlier about the east to west. So that's the end of the presentation, boys. Thank you for holding your comments, questions, and concerns. I'm very much appreciated. I'm very happy to answer any questions. Let's get over. So whenever you guys are ready here.
You might want to keep your presentation up just in case people want to go back to certain points, and you could refer to it with what you.
Okay. Yeah, good call.
That was awesome, though. I see you added a bunch since the last time I saw it.
Yeah, really wanted to drive home the importance of the coordinate system and the transformations because the entire framework is undermined to such a degree that it's like irreconcilable, right? Like there's no
Yeah.
like there's really no explanation to be given. Like, I mean, like, I'll like hear you out, for funsies. I'm not gonna be a dick or anything, but it's so fundamentally bankrupt, like what they've done here. And this doesn't even get into the other thing, Shane, that I was talking about earlier.
But this one, dude, what it drives home the points. Like you took a really in-depth, detailed presentation with historical facts and scientific history, and you condensed it into like a series of points that's like, here's how they violate the tenets from the postulates of relativity. It's right here in the framework. Here's how the preferred directional speed of light, with whatever the mechanism is a violation of that in of itself. Here's how they account for it. The system actually depends on it. And here's how the preferred coordinate system for the Earth-centered inertial frame is always the preferred frame. If you're at rest with respect to anything, you always get it first. That also is a violation of the current understanding in the framework of physics and the speed of light. So, really well done, dude.
Thank you.
And just to notice, is what we're dealing with here is Wang is still trying to postulate that we're somehow moving around the sun. So any ballers that might have some objections to this, we could probably expect some of the same caveats that they may bring up, because he's got contradictions within his own work. And so if you're going to just criticize
Yeah.
Wang, that's not necessarily like our opinion that he's 100% correct about everything, because he's obviously in denial to some degree himself, but his contradictions are apparent. Maybe if you want to just speak on that a little bit.
Can I ask about that speed of light, the variant and invariant speed of light, and how the variant speed of light was shown?
So the varying speed of light is shown in every interferometry experiment ever. It's shown in all electromagnetic wave propagation, even down to like even tiny what did he say? Or gyroscope or ring laser gyros that are centimeters or whatever in length. So it happens everywhere. And then when they transfer that information derived from that to a new coordinate system, the whatever they derive isn't shown to be an invariant transformation, meaning that that the laws of physics aren't being transferred in accordance with the mathematical structure of the framework of which they're doing this whole role play with. So yeah, sorry, go ahead.
The speed of light is distance over time, isn't it?
Mm-hmm.
So if you have a rotating reference frame like the Earth, then it would move distance over time. So ring laser gyro, SAGNAC, all that sort of stuff would show that anything that's moving with the beam, with the rotation of the reference frame, would take longer because the distance is increased for the light to travel. Whereas if it's moving the other direction, it would be shorter. And that's why the speed of light, the constant c, is only ever calculated two-way, because one way can be changed through things like distance, or even through moving through the atmosphere as it changes direction, which increases distance.
Right. Well, that's the thing,
Does that make
right?
sense?
Yeah, that's the thing, though, right? So in the correct coordinate system where you measure the one-way speed, you accurately get a distance, and then when you transfer it outside of that, where you're applying what your understanding is, that's where they have to make corrections because it's actually not shown to be true, and that sort of violation is the crux of it, right?
I think you have to go over scaling invariance again. I don't think he gets what that means.
Yeah, so I just don't understand the argument. So the argument is that the one-way speed of light is not constant, which that doesn't violate anything. Two-way speed of light is constant, great. And then if we take into account the rotation of the object, we should be able to use the one-way speed as if it's a two-way speed, as if it's a constant.
Yeah, so the Michelson-Morley measurement is a second order measurement, so it's the two-way speed, and it's showing variance there too. That's what's being obscured from you guys, and you're being told that never happened. When Dayton Miller...
No, we understand it happened. We just think it was just like a variable that wasn't accounted for.
If that's your takeaway from it, then that's, okay. So did anyone else have any questions or clarifications or anything like that? Feel free to ask. This is, safe space and all that.
No, it's not. We'll make fun of you if it's stupid.
Nah, I mean I won't though. This shit's hard to learn, bro. Like, you know, it's intimidating. It's easy, and I want people, I want to interest people in looking at it for themselves, and then rather than trying to dismiss it from what they think they already understand about it, because then like once you have the prerequisite information to start understanding like the rule book of these transformations and all that, it just becomes so obvious. Like it's not even in question that that there's a varying speed, preferred direction, and all that. Like he linearized the effect, my dude. Like angular rotation and distance varying is not the causation here.
And again, not to reify the speed of light, because it seems, it's the rate of
Yeah,
induction through the ether that we're talking about, and that's
bro.
the main
What
difference.
what was done was so egregious, guys. So check this out. They did Michelson-Morley with a fringe scale to 5 kilometers per fringe, and they didn't get Earth's orbital velocity. And what they derived was an ether wind relative to how far away it is to the uh, what is it, to the center of it, right? So at the North Pole, right? So same situation with the globe, where you guys are like, oh yeah, the rotation of the globe, 15 degrees per hour, 1,000 miles per hour at the equator, et cetera, et cetera. All that, all these effects, Coriolis corresponding, translation motion, all that stuff, all that would be the exact same, right? The only difference here would be that the varying speed of light in electromagnetic propagation would be shown through this with respect to a stationary non-rotating frame. And like, wouldn't you know it, that's exactly what's revealed. And then so all other coordinate systems subsequent this one are are a role play. Like, I'm not trying to be rude, but it's like you're getting into a fantasy land where it's like, okay, now C is the real thing, and now we can make the coordinate system conform to C, right? So they're gonna take the coordinate system and say the XYZT axes are all dilating, contracting, etc., due to relativistic effects to conform to the measuring stick that they just transferred into their coordinate system, which was shown to violate their Lorentz covariance. You know what I'm saying? So like, it's like the ultimate reification fallacy, because then they'll turn around and say, oh, the Michelson-Morley null result due to experimental error was actually due to length contraction, and it's the exact amount that would be required if you were in this other reference frame. Like, nah, dude, see you laser. There's a varying speed, hands down. Two-way, one-way, anyway. Oh yeah, so sorry. So to continue off of that, dog. So a couple years later, they just redid the Michelson-Morley experiment without applying the same scale to the fringe shift pattern, and they derived an effects corresponding to Earth's sidereal rotation, and that's what Dayton Miller measured again. Repeatedly 5,200,000 times. A speed fluctuation change when corresponding with the sun. How would there ever be a translation of motion like that measured, through a coordinate system that is said to be an infinite vacuum of nothingness, dude? Like, it's so like, I don't know. If anyone has any comments or whatever, but if not, I'm gonna dip out for a little bit. I'm super exhausted after this, but I'll come back. I'll come
Dip
back.
out.
Oh yeah, okay. I'll stay on for a
Don't dip
little
out
bit, but I'm gonna end the thing
right
now.
away. Yes. We don't want to have you get accused of running away or anything yet.
Okay, sure,
Make
sure.
sure that even if some flat earthers in here that are still trying to grasp this have questions, like you said, there was 2 C's. Maybe you could talk about that a little bit and how that.
Yeah, so the C that they're claiming that everyone's told is invariant and all that stuff, right? We're told that that these laws of physics are true and all this stuff, and then so applying that with the postulates of relativity, where the laws of physics are the same in all reference frames, right? So that's what they tell us. Like, that's the final product of what these postulates set up for us, right? But in a framework where you measure against an absolute reference frame to derive relative motion, The relative speed of c is shown to have variance to it, and with that, you can derive accurate distance in a stationary non-rotating coordinate system. And then when you transform that, in accordance with Lorentz covariance, the rules that apply to transformations when transforming laws of physics, the distances should be the same because the c in the ECI reference frame should be the same c that's in the ECEF reference frame. So the transformation should be invariant, but when they transform it, the distance is inaccurate, meaning that they're not equivalent. And if they're not equivalent, then that's a violation of the entire structure, like to a devastating degree.
Right. That right there shows the preferred frame. And if you have an invariant transformation from a coordinate system to a coordinate system, it means the distance, i.e., in this case, the variable c, should in fact be the same and constant no matter what. And the fact that it's not, and they have to invoke sorts of adjustments and corrections in the non-preferred coordinate system after a transformation says it all, if you know what any of those words mean.
Yeah. And this
So,
doesn't. Sorry,
Does
go
that
ahead.
mean that C being invariant and having to be transformed between like two different reference frames? Are you saying that shows that C isn't constant?
C isn't constant, and the laws of physics are not the same in all reference frames. The entire framework has been violated by this, up to and including the
Well, is that
principles.
because
Sorry, go
like
ahead.
if you have two reference frames and two receivers or whatever, and in one reference frame it calculates distances X and in another reference frame it calculates it as Y, that would mean C is invariant?
If the distance derived from the first coordinate system, when you transform that to another coordinate system, if the distance derived is still accurate, then you're good to go, and the assumed value of C is good. It holds true. But the distance transformation
No,
shows
that
that it's
shouldn't be the
not.
case. If you're transferring, like if you've got a observation in a different reference frame, you have to transform it because you'll have contraction applied to it. So C will still be, if you're within that reference frame, C will be constant. But if you're looking at it from a different reference frame, C will be different because it's experienced contraction.
Yeah, I think you should maybe go back and watch it again and revisit that and see if it becomes
Why?
clear as to why that's not the. Well, I just explained it ad nauseum. So
I have a question
Okay,
after you're done with it.
was my summation wrong? That, like, if you're in one reference frame and you're looking at C in a different
the
reference frame, you're seeing the other
proposal
reference
to
frame should be
the
different, like
proposal
speed
to
because it's
so
another reference frame.
the proposal to even transform to another reference frame and invoke length contraction is proven to be something that's not. You're doing that into a framework that's shown to be not true in nature already. So it doesn't.
What framework isn't true in nature already?
The framework in
What
which
part
they're using the ECI and the range measurement equation to measure the varying speed of light, which accurately derives the distance, which shows that the varying speed of light can't be transformed into a coordinate system that says that the speed of light is invariant, and all reference frames will reflect this because it doesn't.
Yeah, I think that's just you misunderstanding what speed is.
I
If
see.
something's in motion, then the distance will change for whatever's measuring the speed.
So
And if the distance
if you,
changes, that means the one-way speed will be different. So that's why we use two-way speeds, because then we can average out those two speeds and come to the constant of C.
so in the two-way speed, it's the same. It's the same derived thing. Maybe you okay. So maybe you should email Wang and tell him that about what you think, and maybe he can explain it to you, because the answer is that you're transforming into a system that isn't true. It's not real. It doesn't represent reality. That's the problem. The laws of physics in this system are not shown to be true.
Yeah, but if I can show that invariant speed that you keep claiming is, that variant speed that you keep claiming is actually invariant, and you've just misunderstood some aspect of calculating the speed and something that will affect the speed one way, then that would mean that there's no problems with anything and that Wang's incorrect. He's just confused one way and two way because one way can have changes to the speed because of distance changes.
So here is the.
I've read his paper.
1 second. One second.
I do want to ask you a question, Alan, when you're done.
Yeah, go ahead.
Okay, a
All
little
right.
more one-way
All right.
Sagnac effect on the Earth.
All right, here's a link to a video of the guy explaining the linearization of the situation. Okay, there's no relativistic framework to interpret this from by which you could invoke anything from.
Isn't that just an appeal to authority?
No, it's appeal to trying to get you to understand the situation that you're not getting. It's just to help you understand it, not an appeal to authority.
What was wrong in my summation? One-way speed of light can have distance variation due to motion or even atmospheric condition. So that means a two-way speed of light.
The
once averaged out, should
Michelson-Morley
give us a constant.
experiment does the same thing too. It all varies, dog. Like, do you not? It's all showing a variance.
Well, just
Look,
for
if
the
you don't
layman,
want to have this
Did you
discussion
did you
today, I'll
did you
just go on
did,
mute, that's fine.
yeah? Did you say that there was another question?
well, I was going to say that just the layman's understanding of this, as far as what we're talking about with the speed of light, what Wang seems to be showing, as well as Dayton Miller and some of these, and you're deriving from a lot of this information that maybe both of them aren't necessarily spot on every single case, but the overall understanding of this shows that we had the only way really to interpret this is with a stationary Earth and an ether wind that has a preferred direction of east to west, and that takes care of all that hits all the marks, right? That and then there's this reinterpretation and reconfiguring of it that they have to do to fit it into the idea that it's the Earth moving instead. But the contradictions are like blatant in that they can't have an absolute reference frame if the Earth is actually moving, right? So there's like some, if you've touched upon that throughout your presentation, but just for anyone else hearing this, it's not really about the speed of light. It's the rate of induction through the ether that really answers it all, and that's what what the takeaway is from what I understand so far. Is it's the ether wind that we're actually identifying, and then to skirt around that, they can call it a local ether wind, like Wang does, and then still keeps the idea that we're moving around the sun or whatever. But then that doesn't work because of the three-ring laser should actually be sensitive enough to get that measurement as well. And then there's like, I don't know, if you want to just kind of reiterate what I was trying to say there, Alan, or
so like Wang was alluding to, in my research, I found, and this was even before I came across Wang's work, is that, the Sagnac effect, surface level narrative appears to be, pretty cut and dry. And they give various different ways to give quote unquote solutions for it. But at the higher levels of understanding of it, these people are still arguing about it and publishing papers about it, and it's still in contention. So this what this effect shows, bottom line, is electromagnetic propagation has a preferred direction. It's faster east to west than it is west to east.
Yeah, and that would only be possible if it's a stationary Earth.
Yeah, and
with the ether wind going east to west. It doesn't work with a moving Earth.
Yeah, the Earth's orbital velocity has never been measured, not even close. And in fact, they just took the first. They just took what they keep getting as the sidereal rotation, and then just told you guys, didn't apply the same fringe scale to it, and then told you guys that it was the sidereal rotation instead, and that due to length contraction, you can infer mathematically that the Earth's orbital velocity was measured in Michelson-Morley. It's like, dude, the amount of what's it called? The amount of like reification fallacy to the extreme is just like insane, especially considering before they utilized the framework, they were well prepared to throw out the results and say that they were null due to instrumental error, even though they were, well accurate enough.
Hey, if you go back to your chessboard analogy there, if you go back to that slide, like, could you explain it again? Like, okay, so then
Yes.
if they're taking that distance now, wouldn't both slides have to, like, just explain it again? Like, if the Earth were moving, then both these squares would have to move, but that doesn't happen, right?
Right. So exactly, dude. So F. So the traditional distance, the way that they would derive it with the coordinate system, right? You have your coordinate system established. You have the location of this thing, F5. You have the location of this thing, C2, right? And the distance between them is, what X amount of units of measurement relative to the coordinate system, right? So it's 4 tiles of measurement away in distance, right? So how the way GPS works is it takes a snapshot of the time that an electromagnetic wave signal is sent, and then the time in which it takes for that signal to be received, and then the difference in that is multiplied by c, and an accurate distance down to the millimeter is derived in a stationary non-rotating frame, which allows for the for the accurate distance to be, for the accurate speed of light to be measured, and then so when they transfer that out of that coordinate system to any other coordinate system that uses c, the distance should still be the same in the new coordinate system, but it's not. And the reason it's not is because there's c is truly variant, it's not invariant. So to then apply it to
or wait, hold on, wait, real quick before C is not necessarily truly variant. C is affected by its rate of propagation through the ether wind.
Right, exactly like dude in the video I said was saying.
Right. So what Dogs is trying to do is reify that there's a consistency to the speed of light, which, if you use the equations and you use all of the conditions that that they derive that equation or that conclusion with, then you can reify that all day. But the problem is that we have an ether wind that's affecting the propagation of the light or the rate of induction. So then that shows that there's actually an ether wind, which is the main point. It's not about the constant speed of light, because speed of light is totally a reification of the model in general. It's not there. Maybe there is no speed of light. It's just a rate of induction.
It's useful. I mean, it's a quantifiable rate of induction, sure, but it has practical uses, and it is like measurably constant, except in these specific instances where it's not. And if you ask them, they'll be like, "Yeah, of course, it doesn't apply to this specific instance, but it definitely works everywhere else."
Right,
Did
but
you
we're not
understand
saying
my pretty simple explanation
that
of like the speed of something changes because of the distance?
Right, real quick, we're not saying that the speed of light varies. It varies because of the medium, right? The medium's affecting
so you guys
the
are presupposing an ether, right?
Well, not presupposing. This is showing that it works with an ether wind and a stationary Earth, and then another explanation isn't available.
Yeah, that framework that framework is what provides the mechanism for the discrepancy, right? So it's not like a presupposition. It would be a presupposition to assume that there's no ether and that the framework coordinate system that you're going to jump into has an invariance of C in all reference frames, including the one that you're jumping out of. So like that's it. So like I really don't know. Like if you can't get past that point, I think we should probably let somebody else talk.
Well, no, I have gotten past that point. I understand your argument, and I'm almost entirely positive that the problem is that you think that we should be able to measure the exact same C, regardless of which reference frame we're looking at from our reference frame. But that's not in relativity. That's why Lorentz contractions in relativity.
That's a misunderstanding.
It is. That's not even his point.
No. It's because there's an absolute reference frame, bro. You can't do that without you can't have that if the Earth is actually moving. Like I was going to say, that's why I had you bring up this checkerboard or the chessboard here, Alan. So explain it again with like, okay, so you're getting that distance from the one square to the other square, right? Now, if it was a moving Earth, both squares would have to be moving at the same rate or a relative rate to each other, right? don't know if Alan's still here. Maybe he
Yes.
went to get some water. You know what I'm saying?
Yeah.
Right. So if the way that they're deriving their results were actually consistent with a rotating Earth, with the axis of rotation of the Earth, then the results would be different. How? Show it with the chessboard. Like you would see both squares moving, right? And because one square is absolutely in one position, and the other one is moving, that you know that one is at absolute rest, and they can't have their special relativity where any reference frame is as good as the other.
Well,
What?
no. Special relativity says that all reference frames are as good as any other, but the
That's what I said.
But yeah. Oh, I'm sorry. I misunderstood what you said. Then I kind of
Yeah,
zoned out a little
that's
bit.
what I meant.
I was looking for water. So yeah. Other than that, yeah.
Yeah. So the fact that square C2 would be the absolute reference frame, which is stationary. That's the point that you're getting to, is that doesn't move, right? And it would move, given that the equations you're talking about and the way that they derive it, it would have to move if it was a rotating Earth. But because it doesn't move, we know that it's actually a stationary Earth for sure, and a moving ether wind.
So what's the absolute reference frame you're talking about?
The absolute reference frame is the way that you mathematically measure relative motion. So like that's all they're inferring by the reference frame, right? They're saying that if you derive relative motion from this reference frame, but in the Einsteinian coordinate system and all that, to be everything derived in that from C should be an invariant transformation. So again,
Okay, so according to Einstein, we shouldn't experience relativity in a absolute reference frame. But what's the actual absolute reference frame you keep referencing?
he says that that there's no preferred reference frame, meaning that in this exact example, if there is shown to be a law of physics that doesn't carry over with a transformation, then that invalidates the framework. So lo and behold, the range measurement equation in the ECI show a actual varying speed of light that when accounted for derives distant accurately when you're relative to, or when you derive it for the one-way speed. And
Yeah, so the known
oh,
rotation
will
of
you
the Earth
stop,
causes speed of
dog?
light to change and we account for it.
Hey, dogs, let him finish.
He
Please.
linearized it, bro. There's no rotational effect. It's linearized. Like
Okay, so why does a ring laser gyroscope measure motion in all coordinates except for the one that would be, to you, rotation of the Earth, 15 degrees an hour? But if you move it in any other direction or anywhere else in the Earth, it'll register that motion. But it's affected by motion in every way except for the ether wind just happens to specially do it to 15 degrees an hour. It makes no sense. It's believing in something magical when we already have an explanation that works.
you don't understand that you don't have an explanation that works, and the ring laser gyro picks up motion when axially aligned with the axis of rotation. That's when it picks up the biggest French shift pattern. So when it's axially aligned with the rotation of the ether wind or the rotation of the globe in your guys' case, the results would be the same for an ether vortex and a translation of motion over a plane.
Well,
So the discrepancy shown. Well, we would actually, because GPS has the preferred recipient that's also in the coordinate system according to you guys actually moving, and it's shown that he's not. So it's actually not that. So that's actually not the case. So
the preferred recipient and the preferred reference frame are just a reference frame that the receiver's in, right?
yes, it's a mathematical invalidation of the mathematical framework that you're invoking to say that things like contraction due to angular momentum or space-time curvature are invalidated by.
And so the non-preferred reference frame in the case of GPS would be the GPS satellites, right?
Yeah, but who gives a shit about another reference frame if the other ones are invalidated and your postulates are contingent on a lie?
Are they invalidated simply because we call Earth a preferred reference frame?
No, they're invalidated because they're shown to be a preferred coordinate system and that measures an accurate speed of light when you derive the distance from it using the range measurement equation. It's not a relativistic effect. That's not an angular momentum effect.
Okay, so what's the absolute reference frame in this?
I think you're looking for. I don't think you understand. I don't. What is your what, man?
Just stop talking to dogs. Is my advice.
I can't. I can't. You
One
need
more time. Just one more time, and then I can go away. It's fine. One
zero more times. Just go
Don't
and
shoot him
rewind.
one more time. Yeah, there you go.
0 times. Just go and rewind. I can't anymore.
Well,
You were the only interaction, so I was kind of doing it for the class. But like,
well, you know what? I'm surprised Kosho's not here still, or is he? Did he leave?
I don't know. He said he had some stuff, but he might have more questions now, or like different questions now.
He'll probably go ask some other Globers what his reputation should be, and then get back to you.
Is he in the room still? I guess I wouldn't be surprised if he disappeared, but seems like he did maybe. Kosho, you still here? Anybody? Any other even flat earthers have some questions that we could try to just explain this again so that Dogs doesn't have to be the only person that's just reifying his model to try to.
Dave. No.
No, I don't. Alan, do you want to try to? Can you restate your question again?
I have him muted, man. Like, if it's the same thing again, like, I don't care. And if it's a slightly different one, like, you can figure it out or whatever, or try and steal me. For homeworks, try and steal me on what you think my response would be.
Real quick, hold on, everybody. Right, real quick. Hey, Al, hold on a second. I'm gonna talk over. Both.
I thought you said you were gonna politely go away.
He's a weed,
No,
dude.
he's just gonna say that that we chased him off because we couldn't handle his questions.
He's done.
Oh, I mean, I'm okay with that. Like, I can live with that if he can. So.
Yo, Alan.
What up, G?
For future reference, though, don't mute someone. Just like turn them down, so at least you see when they're lit up and talking, so you don't talk over them.
Oh, okay. Yeah, dude. I apologize.
Oh, he laughed. Well, I'm just gonna say why Alan's a fucking idiot then, and then blah blah blah. I start going off because you.
So. I'm sorry. Yeah, I apologize. Good call. Yeah, my bad.
No worries.
Doing pretty well, Alan. Good for you.
Thank you, sir. Thank you.
Yeah, but what was he basically trying to do? He was just like he just didn't understand it. Could you just reiterate for us what he didn't understand, real quick?
Dave, I think you got a pretty good idea. Why don't you take a shot at it?
Dave,
I think you can probably do
Dog, you were low-key taking lead on it. So he's just reifying the model, and he's looking for an absolute reference frame and some terminology, or like he has some different definition to it, or like I don't know what he's looking for. In terms
the first
of it,
time,
like
he put contraction into it, so he's obviously buying into the whole length contraction thing too.
That falls into the reification of the model.
Yeah, I thought he was just trying to bring up points of contention with what you're saying. He was trying to attack what you're saying and not really addressing.
Well, his whole point was that it differs depending on the framework, and that's the whole point of Lorentz contractions, which shows a shocking misunderstanding of the premise of the argument. But I mean, that's just dogs. They're looking for any which way to go. No, I don't have to listen to anything you just said, or believe it, or worry about it, or even learn what you said. I win. Yeah.
So what he said is, we can still figure it out. I don't have to demonstrate it for you, even though it hasn't been done. It could still happen.
Well, that's what all high-level academia is saying, basically, through the 12 plus different iterations of how they possibly derive the Sagnac effect. It's like,
but every
Yeah.
Every Glober has to say that you don't understand it now, and that's got to be their standing
Oh,
point. Otherwise,
I mean,
they look silly and don't know what to say.
yeah, I'm comfortable with that. I mean, there was a point when I didn't understand it, and I may, like that might have worked or whatever. But
Yeah, I thought that was awfully basic too. He went to the basic bits. You or him or whoever you're getting it from, there's a misunderstanding here somewhere.
yeah, maybe this guy whose whole career is based on interferometry and GPS, maybe he forgot. You like, come on, boys.
Like, I guess when you're
Oh,
low hanging fruit, you can only see what's hanging at your level, though.
yo, that video you played, I've never seen before, and was awesome.
Yeah,
Awesome.
yeah,
That's the guy, the Hatch guy, who did the actually correction when they proclaim that relativity is like how GPS is.
right.
Like, actually, he had to fix it because it doesn't specifically. That's the guy, right?
That's the guy. Yeah, and he actually
Oh
worked with
man.
Wang too. And then so check this out. So somebody in the comments was saying, oh my god, a plasma cosmologist, Rafflecopter. Like, I can't believe you would cite such a stupid person or whatever, right? Well, the reason people changed cosmologies, home dog, is because they realized that math has rules to it and that the rules are being violated. And in their highly specified technical fields where they deal with these so-called relativistic effects, they found that they're not attributable to the things that they're saying, and that there's some sort of cover up going on, and they're not really prepared to say, hey man, I think it's a stationary flat plane with rotating, or relative to a rotating ether or whatever. So they're like, yeah, maybe it's just plasma out there, boys. And they could take less heat, and they could just take less heat from that. So your boy Ron Hatch, look him up. 27 patents are held by him for GPS. Like, if anyone knows about the technology or how to derive the Sagnac effect and the mathematics involved, it would be that guy. And specifically when he shows that the linear effect is fully well able to derive the angular effect, the rotational effect. And I mean, that's the way he explained it is it's just a function of length, and there's a preferred direction that shows the variance. I mean, that's what more could you ask for? Oh my god, plasma cosmologist. Yeah, he became a plasma cosmologist because he realized the exact thing I'm trying to tell you guys, and you guys are saying, no, you don't understand, you're wrong. But I mean, it's cool. I mean, it's cool. He might be wrong, but doesn't seem like it.
I got a plasma TV.
This is a reference.
I'm wondering,
Have a reference frame. Have a new reference frame, right?
Isn't there a guy? Yeah, there's an older guy who had a plasma moon theory. Maybe not the entire universe, but just the moon was plasma. There's a theory from Antiquity about that. If you can find that, I can't remember the guy's name right now.
Yeah. All right, cool, man. So I think we wrapped it up here. And if anyone has any questions, comments, concerns, feel free to add me on Discord, highlight me. If you're going to highlight me and say something mean and derogatory, don't be surprised if I don't answer. But if you have legitimate questions and you would like some clarifications on something specific, feel free to hit me up. I'm happy to share what I've learned, and that goes for globe earth proponents too. If you want to learn the argument and better understand where it's coming from and elevate your understanding of it, feel free to hit me up. So thank you for your time. I appreciate everyone going through that presentation. I know it was kind of lengthy there and a little
I have to say,
and maybe a little redundant.
I can't believe it. No ballers. No, they all left the room again. So we had just the dogs with his reification stuff, and any other ballers at all have any other questions or comments or anything that objects to what he was saying. Nobody again.
That was awesome, dude.
Hey,
Well
Alan,
done.
I sent you a video.
Get ready.
That was good.
Get ready for
I sent
your.
you a video on the plasma moon, so you know the guy and the scientist, and that's a good place to start. Sorry, Shane.
Yeah.
Get ready for your rendition on Globebusters next, I guess.
Yeah, absolutely. That was the dry run. So I just finished it up today. I think that pretty much covers everything I wanted to cover in it. Did you guys think any feedback? Is it too lengthy? Any parts need cut, moved? Was it all kind of coherent, straightforward, and how I laid out the summary and then the components all cohesive?
You should look into that guy because when you were talking about it, I'm remembering watching all his plasma moon theories. So they'll probably coincide, which is collaboration, more than one person.
Right.
You can read a little bit less of the stuff, right? I don't know. if you guys give it to people afterwards, maybe, and then you can have them read some of it themselves. Do you plan to present the PDF like the one that I have? I think is even old. You keep editing it, but like
So
Yeah,
the
I
new
noticed that you were reading it. You had like kind of like some of the things that you already knew in your head that you were adding in or not saying
yeah,
because
because
you've
like
gone through.
yeah, personally, like when you'd read it like verbatim and then you'd have a thought, I was much more interested in your thoughts than you
Yeah,
reading the thing that I was reading.
then the
like
verbatim thing.
you could
Yeah,
summarize like, those 2 paragraphs into 3 sentences of your own,
yeah,
and
that
still
would
have
be
the text.
ideal. That would be ideal.
Hey,
So
I got a
just
But
question. I
you
got
could
just
keep
real
the
fast.
text there. You could keep the text there and then put a little aside thing if you want, and then and like basically your summary that your 3 sentence summary that you could either choose to read or let them, you know, have the slide to look at later or something like that.
oh, okay, I
Like
see. So when going over the postulates for special relativity, instead of like reading them verbatim from the PDF, just skip to the summary and then like tell it through that, so it just knocks out an entire
Yeah, if you
slide.
it doesn't leave
me,
out a whole lot. And then at the bottom, like just a summary of the overall gist of each slide. Like at least do that.
Okay.
yeah, like the actual notes slide. Like how you can write notes that aren't actually reading the slide, but the stuff on the slide backs up the stuff you're saying that you already pre-wrote.
Sure.
I mean,
Hey, I
just
got
if we're nitpicking. Sorry, Larry.
no. I
But
want
no,
to.
if you're looking for suggestions, that would be the only thing I'd say. Yeah.
Yeah, I want to go, or I want it to be, quick and cohesive and stuff. But I also realized that it's a lot to go over, so I wasn't sure how to close the gap. Was it just to like add more stuff and read it slow and then talk about it, or was it just to summarize and breeze through? Um, So yeah, no, I appreciate the feedback. And Larry, you said you had a question, bud. What'd you want, or what was your question?
Yeah, sorry, I've been screen recording for the past hour and 40 minutes. I was wondering if it was okay for me to upload this to my YouTube channel or should I just keep it private?
No, you can absolutely upload it. I'm gonna have a recording of it too that I'll upload on my channel. But yeah, absolutely, man. Do whatever you want with it.
All right, I just wanted to make sure that I wasn't crossing any lines that I was unaware of. Thank
Oh no, you're straight, dude.
And
I
That's
appreciate
cool.
it.
Just
for
like
everyone.
throw his YouTube space audits and throw his like Telegram in there, and then I'm pretty sure it's anything goes, just like Wissam says, right? Take it,
Yeah,
use it, do it, do whatever you want.
I
yeah.
just got a quick question. Alan, do you have like a Google document or something that or could you put it into a Google document form so that we could just at any time open our phones and have all the information that you've presented? Like, because I want to talk to some people in real life about this and just run it by them and
So
see
if
what
you
they
have
think.
Telegram, I upload PDF versions and PowerPoint versions of this, so you could just download the PDF version, pull it up on your phone, and then slide through it like that. Is that kind of what you're looking for?
Perfect. Yeah. I'll get the telegram from
Yeah,
somebody.
cool.
I'm driving right now, but yeah.
Yeah, cool. I'll DM you the link or I'll put it in the
Boom.
thing. Yeah, oh, you got me. Thanks, Shane. Appreciate it. So yeah, just hit that up, follow it, and it'll be up there soon. And then yeah, you could just reference it from there
Thank you.
to
Yeah, the PDF is pretty awesome, right? Which is just like the printout of all your slides. But by itself is a hell of a thing. Like now I can loosely talk about it and make the argument and quote the same stuff and just throw snapshots in. Like, dude, I scared off Research Flat Moon that way. He was asking dumb shit, and I was like, the SAGNAC is not scalar invariant. He was like, all right, I don't fucking.
Yeah, ideally your slide should contain little text and more image, charts, or plots, and then the focus should be on what you're talking about rather than have your audience read the slides. For sure. For sure.
I was like, yeah, maybe I won't do that though. Because,
For sure. Oh yeah, yo, Parks, I had to get a new Discord. Is he here?
yeah.
Oh,
He's in the text, right? That's not what you
Professor
asked.
Park.
He's not
yeah.
in the VC. He
Oh, he's
might be
not.
listening.
Oh, he's not in the VC. I was gonna say I got a new Discord account. So if you want to re-add me, but he's not in VC. You said.
He's not, but he might
Unfortunate.
be listening. Yeah.